Bearing materials. Bearing supports moving parts such as shafts and spindles of a machine or mechanism. Bearings may be classed as rolling contact plain bearings. Rolling bearings are almost invariably made of steel that can be hardened after machining. Both plain carbon and alloy, namely nickel, chromium, molybdenum steels, are employed for different applications. For making plain bearings, an extremely wide range of materials is available. Bearing materials. A bearing material should have the following properties: possess low coefficient of friction, provide hard wear resistant surface with a tough core, have high compressive strength, have high fatigue strength, be able to bear shocks and vibrations, possess high thermal conductivity to dissipate heat generated due to friction between the bearing and the rotating shaft, possess adequate plasticity under bearing load, be such that it can be easily fabricated, possess resistance to corrosion. Bearing material should be softer than the shaft material, possess anti-seizure characteristics, possess ability to embed in itself any dirt, etc. present in lubricating oil, should be cheap and easily available, etc. Bearing materials types: lead or tin based alloys, white bearing; cadmium based alloys, aluminum based alloys, silver based alloys, copper based alloys. Sintered bearing materials, non metallic bearing materials, or plastic bearing material. Selection of a particular bearing material depends upon types of loading, running speed, and service condition. Bearing materials: white bearing material, tin or lead based alloys. The high tin alloys with more than 80% tin and little or no lead. The high lead alloys with 80% lead and 1 to 12% tin. The alloys with intermediate percentage of tin and lead. In addition to lead and tin, these bearing alloys contain antimony and copper also. Composition of lead based alloy: lead 75%, antimony 15%, tin 10%. Composition of tin based alloy: tin 88%, antimony 8%, copper 4%. Bearing materials: tin based bearing alloys, Babbitt metals. The tin based bearing alloys are of better quality high duty bearing metals than the lead based bearing alloys. Uses: suitable for use in many medium and high duty bearing applications, particularly in the automotive industries. Lead based bearing alloys, cheaper than tin based bearing alloys. Uses: low pressure, low speed bearing applications. Bearing materials: cadmium based alloys. Composition: cadmium 98%, nickel 2%, silver 1%, copper 1.5%, zinc 0.75%. Have a structure consisting of a soft matrix containing harder crystals of intermetallic compounds. Not very popular because of high price of cadmium. These bearing alloys possess greater compressive strength than tin based alloy. Cadmium based alloy possess low coefficient of friction, high fatigue strength, high load carrying capacity, low wear, good seizure resistance, fair ability to embed dirt, poor corrosion resistance. Bearing materials: aluminum based alloys. Composition: aluminum 92%, tin 6.5%, copper 1%, nickel 1%, silicon 2.5%. These are two-phase alloys for use in bulk form or as linings on a steel base. Aluminum base alloy possess excellent corrosion resistance, fair conformability to journal, good ability to embed dirt, good seizure resistance, good thermal conductivity, high coefficient of expansion. These alloys find applications as bearings. Bearing materials. Copper based alloys. The term bronze covers a large number of copper alloys with varying percentage of tin, zinc and lead. Bronze is one of the oldest known bearing materials. Bronze is easily worked, it has good corrosion resistance and is reasonably hard. Composition: copper 80%, tin 10%, lead 10%. Tin bronze: 10 to 14% tin, remainder copper, is used in the machine and engine industry for bearing bushes made from thin walled drawn tube. Copper based alloys are employed for making bearings required to resist heavier pressures such as in railways. Bearing materials. Sintered bearing materials. Copper powder with 8 to 10% tin and sometimes with 1 to 3% graphite is used for making porous sintered bronze bearings. Besides using bronze powder, iron powder has also been tried for making sintered iron bearings. Such bearings possess greater strength. Sintered iron BHN 35 to 45. Sintered iron and lead BHN 40 to 60. Sintered iron and copper BHN 45. Bearing materials. Non-metallic bearing materials. Teflon, polytetrafluoroethylene PTFE. It has coefficient of friction more or less than 0.04 without lubrication. It has good stability at high temperature. It is chemically inert to water and many chemicals and solvents. Fillers like glass and graphite increase the resistance to deformation. Nylon or polyamides. Nylon bearings have coefficient of friction 0.15 to 0.33 for dry friction, 0.14 to 0.18 with water lubrication, 0.09 to 0.14 for oil lubrication with a load of 5 to 25 N and a relative velocity of 2.5 to 110 meter per minute. They are used for low load applications, particularly where oil lubrication is impossible or undesirable. Bearing materials. Superalloy is a general term used to describe the nickel base and cobalt base alloys which have been developed for use at elevated temperature. Superalloys produce a combination of high strength at elevated temperatures, resistance to creep at temperature up to 1000 degrees centigrade, and resistance to corrosion. Typical applications of superalloys include vanes and blades for turbine and jet engines, heat exchangers, chemical reaction vessel components, and heat treating equipment.